Okay, so we are going to start our quadratics unit with a little intro and some pictures. So the first thing I want to note is that standard form of quadratic. When we talked about this during factoring, but I want to reiterate, a standard form of quadratic is y equals a x squared plus bx plus c, where a, b, and c are all normally replaced by numbers. There goes my lights, but that's okay. They turn back on, kind of. I also want to note that we can see this as function notation as well. So a function of x, we've talked about this in the evaluation lessons, and it's ax squared plus bx plus c. And again, I want to stress this is the standard form of a quadratic. We are going to learn about a couple other forms as well. But note that the quadratics always have that squared as its highest exponent. So it looks like this U shape. So we're going to write U shape. And that U shape can also be upside down. And it has a special name. And this U shape special name in math is a parabola. Try saying that 5 times fast. Parabola, 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 parabola. Yeah, exactly. But it's called a parabola. So a quadratics shape is called a parabola. So here we have an example of a parabola. Here's a quadratic. And now we're going to talk about its domain and range. So we just went through a unit about domain and range real quick. So we're going to think about it as, that highlighting the x and the y. So I'm going to take two different colors. And for my x, see how far on the x it goes? Well, let's see. There's an arrow this way. And there's an arrow this way. So my x's seem to go like that. All u's have this bottom dip and it stops it there. So my y seems to have a stopping point here, but go all the way up in this example. So to practice domain and range for this specific one, domain goes all the way x and y. And if I flip this u over, it would do the same. If I move this u up and down, it would do the same. So all parabolas have the domain of negative infinity to infinity, aka all real numbers. The range for parabolas differ depending on if it's a U or an upside down U. Depends on what it does. If it is on the bottom and goes up, it goes up forever, definitely, but it always has a number, and we're going to give that a name in a second, and it goes to infinity. Here, it starts at negative infinity and then stops at that number. So this is what domain and range for parabolas are going to look like. Obviously, we're going to insert the correct information depending on what parabola we are looking at the time for our range, but domain always is all real numbers. So now we're going to start putting together parts of the parabola, add in some vocabulary. So the first vocabulary I want to show you is here's a U, and U's are always split directly in half and can fold over. So that idea of folding over and being equal on both sides is symmetry. You might remember this from geometry, or you might remember this from elementary school. So there's always a line of symmetry. It's invisible. It's an invisible line. It's not part of the graph, but it helps us a lot. So we do identify the line of symmetry, and we always identify the line of symmetry as x equals a number, because I should put a number sign there. Because x equals a number is an equation. It does give us a line equation. So for example, in this picture, we've got that line of symmetry splitting this upside down U. It's also called the axis of symmetry in some textbooks, which comes to its nickname, the AOS. So you can use all those different notations, and you may see all those different notations. parabolas also have a very important thing, and that's what I was referring to as that low dip of the U. And the bottom of the U or the top of the U is called the vertex. So in this picture, the vertex is at the bottom. And because it's at the bottom, it's the lowest point of the U. It's the minimum. In this picture, the vertex, where the arrow's not lining up because the computer messed that up, is at the top of the U. It's the highest point on the graph. If it's the highest point of the graph, that makes it a maximum. So this point on the U is always called a vertex, but depending on which way the U is facing, makes it a minimum or maximum. There are some other parts of this graph. We have the y-intercept. Now, notice here the y-intercept isn't anything important. Notice here the y-intercept isn't anything important. It's still crossing the y-axis, so it is an intercept, but it's not a significant attribute to the parabola. Oh, look, it says maximum right there. There we go. Now we have a new idea of x-intercepts. So we found x-intercepts with lines, but they weren't as significant as they are going to be in a quadratic equation. Quadratics revolve around x-intercepts. Here's our x-intercepts here. We're just going to put that on this line instead. X. In fact, quadratics revolve so much around x-intercepts that they have 4 different names that are synonymous with each other. And those 4 names we're going to go over almost every day, and we're going to focus on so much. And those 4 names are x-intercepts, solutions, roots, and zeros. And you're going to see these pop up again and again and in different forms. You're going to see them on a graph. You're going to see them in the equation itself. You're going to see them come out with a special relationship to factors, which we've just worked a lot on. So they're called x-intercepts, aka solutions, aka roots, aka zeros. And you're going to need to know that for sure. So now that we know what a parabola looks like, we have an idea on its significant points, we're going to go more into quadratics. So if we turn the page, we're on page 2. In this section, we're going to show that you can identify quadratic equations. So we're going to recap some stuff that we just went over in our pictures, and we're going to learn a couple more things. So a quadratic function, again, standard form, is y equals ax squared plus bx plus c. And a parabola is that U shape. It's the graph of a quadratic. So now you're going to fill out these tables to graph each of these quadratic. Notice how here it doesn't have a long bx plus c. Well, that's because b would be 0 in this case and c would be 0. So this is still a quadratic. It's still an x squared. So now you're going to take the time and you're going to fill out this table with the right numbers, and then you're going to graph them on this and this graph. So go ahead. All right, so this is what your table should look like. Negative 2 times negative 2 is a positive 4, hence all these are positive. These have all negative signs, so you put the negative signs to all of them. which means if you go to graph, you have a picture like this. And a picture like this. So now that we have some examples of some tables and some graphs and tables that were given by equations, let's see if I can try to see more of this page without getting in the way. Don't we love technology, team? The graph of a quadratic function. So again, a quadratic function looks like ax squared plus bx plus c, where a, b, and c all numbers, is called a parabola. We don't want to forget that word parabola because we are math class. We're going to use math words. And every parabola is U-shaped. If the lead coefficient, so the lead coefficient is a, right? So that's just saying the number next to x squared is positive, the parabola will open. Well, here it's positive. How does it open? It opens up. So I like to think about it as positive face is a smiley face. The lead coefficient is negative. The parabola will open down. I like to think of this as negative is a sad face. So now, real quick, I want you to go through A through F and identify the lead coefficient, if it's positive or negative, and then say if it opens up or down. So take your time to do that now. All right, here are your answers. The lead coefficient is positive, so we go up. Lead coefficient positive, we go up. Lead coefficient negative, so we go down. Lead coefficient negative, so we go down. Lead coefficient, oh, they moved it. Be careful. You gotta look for the number next to x squared. It is positive. Goes up. And again, they moved it. That's negative. It goes down. Check your answers. Hopefully they're correct. The blank is the highest or lowest point on the parabola. So as we mentioned before, that's that vertex. The dip in the U. Boop, 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 boop. The parabola opens up. So remember, if it opens up, then the vertex is at a minimum. If the parabola opens down, so that's the sad face, the vertex is at a maximum. So again, minimum, maximum. Flip the page for some more notes. I want you to identify the vertex in each of the parabola and then say if it's a min or max. So take a moment, identify mins and maxes, and point to that vertex and label that point with a coordinate. So here you go, take a moment. All right, let's check your answers. Right there is obviously the vertex. It is at 1, 5, and it's at the top, so it's a max. Here is the vertex. Its coordinate is -2, 1, 2, 3, 4, 5. It's at the bottom, so it's a minimum. Now, this objective is that you can find all the zeros of a quadratic function. So remember, I said zeros is really important for quadratics. Zeros are so important that they have 4 different names for zeros. So the first name for zeros is obviously zeros. Then it's also x-intercepts. It's also solutions to x, but we're just going to call it solutions. And lastly, it's roots. So zeros are the x-intercepts of the graph, but zeros are also the solution to x when we go to solve the quadratic equation. They're also called roots. And why are they called zeros? They're called zeros because if they are x-intercepts, think of them as where y is 0, what is x? Get it? X-intercepts, zeros, they all kind of make sense why they're named that, except for roots. But like I said, these are so important that they come up all the time in quadratics. So think about it as it's like the roots of this unit, you know? So that's a good way to think about all of that. So now find the zeros, aka x-intercept solutions, roots of each of these graphs. So give it a second and you're going to go label them. You can label them as an x-intercept or you can label them as x equals, whatever you want. All right, let's check your answers. Well, there and there are the x-intercepts. So that's at x equals -2 and 2. You could have also wrote it as -2 comma 0 and 2 comma 0. Here it only has 1 0, and that's at x equals 1, aka 1 comma 0. What did you guys put for this? Well, remember, it's zeros, so they're x-intercepts. Does this ever intercept the x? No. So there is no real solutions. Now, there's a reason why I wrote no real solutions, and that's because soon something's going to come up and it's going to be called imaginary numbers. So there are imaginary solutions, but we're not going to get into that right now. I do want you to note that in this picture, you got 2 zeros. In this picture, you got 1 0. And here you got 0. So it is safe to say that for a quadratic equation, you could have 2 solutions, 1 solution, or no solutions. You cannot have 3 solutions. You cannot have 4 solutions. You can only have as many solutions as the highest exponent indicates. And then you can also have less than that. Now we're going to wrap together the whole idea of quadratics and factoring. So we are going to solve for the zeros by factoring. Write the zeros as a coordinate point, and then we're going to plot them. So we know how to factor each of these. So real quick, I want you to take a moment and I want you to factor all of these. All right, let's check your answer. This is a simple factor equation. So it's x and x. Factors of 6 that give me 5 are 2 and 3. Here, I have an x and an x. I need factors of positive 12 that gives me -8. So that's going to be a -6 and a -2. X and x, factors of -15 that give me -3. I want a -5 and a +3. But we want to solve for factoring. So that's when we solve for zeros. So that's when y equals 0. So we want to set this up as 0 equals these things, which means x can equal -2 or -3. Here, if we set up as equals 0, x can equal +6 or +2. We set this up equals to 0. X can equal +5 and -3. How did you get that, I ask? Well, I took each one of these and set it equal to 0. Did opposite operations and solved. But if you notice, there's a pattern every time. What is the relationship between these factors and the zeros? Well, this is x plus 2, and the answer is x equals -2. They are always opposite. This is crucial that I wrote this. This will come up over and over again. So not only are zeros so important, they have 4 different names, but then they also have something that's the exact opposite, and that's factors. And I just want to note that factors are in parentheses. Factors have an operation. Zero solutions, roots, and x-intercepts, they're written as x equals that number. or they're written as coordinates. So factors, roots or solutions, or x-intercepts, or zeros. So now I can take these and I can actually plot them on the graph. Here, this is 6, 0. This is 2, 0. And here, this is 5, 0, and negative 3, 0. We're going to take this further and actually figure out how to graph these. And we can do this by knowing the line of symmetry cuts these in half. So if these are the zeros, the line of symmetry has to be directly in the middle of them, right? So what's directly in the middle of negative 2 and 3? 1 is. What's in the middle of 2 and 6? 4 is. What's in the middle of negative 3 and 5? Well, that's hard to eyeball. Well, I think it's 1. Let's double check. That's 1, 2, 3, 4 spaces. That's 1, 2, 3, 4 spaces. Yep, it's positive 1. And now we just need to know where the vertex is so we can graph it fully. Well, how do we figure out the vertex? We figure out the vertex because the vertex must be on the axis of symmetry, which means the x value of the vertex equals the axis of symmetry number. So in this case, if I was making my vertex, my x must be on 1. Now I just need to figure out my y value. Over here, my x value of my vertex must be at 4. Over here, my x value of my vertex must be at 1. So how do I figure out those y values? Well, I have an x value. I have an equation that takes in x's and spits out y's. All I have to do is plug in 1 where I see the x's. So that would be 1 plus 5 plus 6, which equals 12, right? 1, 6, 12. So then I go to 1 up 12, which is all the way up here. And I rough draw my shape. Here, I'm going to plug in 4. Here, I'm going to plug in 1. And those are my y values, and you should continue graphing from there. So you're going to finish that out on your own without me giving you the answer. And that's our intro to quadratics.